What's up, everyone? Welcome to this exciting webinar. I'm here hanging out. Actually, Alessandro is right beside me, but we're using two computers to do this training. Really pumped up about this because we're going to be diving into oil management. We're going to be diving into really what technicians need to know about CO2 oil management. And we're going to be diving into some different things. We're going to be focusing on some of the CO2 fundamentals that we need to know because we got to go there. We're going to get into some applications. We're going to get into some commercial stuff. We're going to get into some industrial stuff. We're going to be going through some diagrams. So take lots of notes because we want to talk about piping practices. We want to talk about the separators. We want to talk about the reservoirs. We need to know how all of this stuff works. And it's so important that we understand each and every component here. Okay, so Alessandro, organized PhD. This guy is a CO2 expert, oil expert. We've had lots of great conversation, writing white papers. Like this guy got it going on. And now we're going to be diving into what we need to know about oil system. Alessandro, take it away, my friend.
All right. Thank you very much, my friend. So, yes, the title of our presentation is What Technicians Need to Know About CO2 Oil Management Systems. So I put together here these topics to discuss the compressor, CO2 applications, compressor lubrication systems, oils, oil management. We discuss the basic, and then we go through to commercial and also industrial, and I will give you an example how to use our new software named Fender as a service tool, especially to for troubleshooting, not only for designing system, but for troubleshooting and come up with a solution when we have oil issues.
Yeah, and Alessandro's been showing me Fender, and we've been walking through it. And like when we get to the end, you're going to want to stay till the end to show you all the set points that they have in there, and as he has, so like you can really fine tune a CO2 system just by these different set points. So I'm super excited to walk through that with him.
All right, let's start with the compressors for CO2 applications. So Bitzer released CO2 compressors a long time ago. So the first prototypes came to the market more than 20, almost 30 years ago.
Yeah.
And today, of course, these numbers are always change, of course. So probably we have much more than 60,000 supermarket solutions using Bitzer products in general, right? So yes, let's discuss this. CO2 is gaining traction in several HVACR applications worldwide. So this because of its eco-friendly attributes, low price, and favorable thermodynamic properties. So as you can see here, we have not only in supermarket, grocery stores, we also have in cold storage facilities, grocery distribution centers. We have in mobile applications, marine, data centers, ice rinks, arena. In this presentation, we discuss a little bit about the ice rink applications and water parks, aquariums, hotels, district heating, cooling, food processing plants. So CO2 is basically being applied in many sectors. So here we have global manufacturers like I put here the web page we have in US and globally. So these are CNC small, medium, and large compressor racks with our compressors for different kind of applications. So
yeah, there's a lot there.
A lot, yes.
And I was just out at the Euro shop there last week, and there was a ton of Bitzer compressors on different rack manufacturers, and I see quite a few of them there. Like all those, pretty much all those ones were there. So
yeah, I saw a lot of pictures you posted on the LinkedIn, and it seems that the green color was dominating the show. So yes, let's discuss the Bitzer solution, Bitzer products for CO2 applications. As you can see here, we have compressors for subcritical applications, we have the SL series, ME series. We have for transcritical applications, the TE series. We have Ecoline Plus. This is designed with the line start permanent magnetic motor, the so-called LSPM motor. We have solutions with the VariPack. We have IQ modules as well. We have the VariStep, a combination that gives you an alternative for VFD to control compressor capacity. We also, here in US, we manufacture pressure vessels, flash gas tank, liquid receivers, suction accumulators, oil reservoirs. And we also have a shell tube gas cooler ejector. So ejectors are also available for CO2 applications, especially for high and low pressure lift applications. So let's discuss a little bit about the compressor lubrication system.
Yeah.
So we have different lubrication system. So oil pump lubrication is designed for 6 and 8 cylinder compressors. We have oil pump, as you can see here.
Yeah.
This is valid for both subcritical and transcritical compressors. So sling compressors are designed with a centrifugal lubrication, 2 and 4 cylinders. We have this centrifugal disc, dynamic disc, responsible for lubricating the moving parts of the compressor. This is also valid for subcritical and transcritical 2 and 4 cylinders.
So Alessandro, one of the questions I get asked by technicians a lot, well, why do I have a dynamic disc in smaller ones and I have a pump on the bigger one? Do you want to explain why you have to go to a pump style on the bigger compressors?
Yes, this, especially for smaller capacity, this is to reduce the cost of the compressor. So, and Bitzer has this configuration using the dynamic centrifugal disc, not only for CO2, but for small 2 and 4 cylinders. For the Ecoline series with the standard refrigerants. Mm-hmm. And yes, 4 cylinders, C4 for standard refrigerants, we have the possibility to have both options with the oil pump and the slinger as well. So, but this is related to cost, to answer your question.
So could you do dynamic disc on a 8-cylinder?
No, for large capacity, it's not so easy. So we needed to have an oil pump for large capacities when we have more, moving parts on the compressor. So oil pump is the best option.
Yeah, because you got a longer crankshaft now, you got more journals for all the pistons and the rods. And with the dynamic disc, you don't have any positive display, right? Positive or centrifugal force correct. Of the oil to push through all the way through the crankshaft. Fantastic.
That's correct. And I put it together here, the function of the oil, that is very important. So yes. We have CNC lubrication, sealing gaps, cleaning and protection, internal cooling. Our compressors doesn't require, our CO2 compressor doesn't require any internal, oil cooler. So, but the one of the oil function is to cool the moving parts. And sound attenuation is another function of the oil.
Wow. Yeah, because that's super important, because if you've seen it even with HFC compressors, if you're low on oil, there could be more vibration in any compressor. It doesn't matter the compressor. Like if you got low oil, there's more vibration, there's more noise. So that makes so much sense.
Exactly. Yeah. So, and in terms of the oil protection devices, this is what we offer for these 2 designs, with the oil pump and with the centrifugal lubrication. For oil pump, we have this device named Delta P2, and the OLC K1 for centrifugal lubrication. So regardless whether you are using an oil level controller, So this is our primary oil safety. So because the oil level controller just control the oil level, but this Delta P2, for example, the oil pressure switch, it measures the differential pressure in the oil pump. So especially if this is not only for CO2, but imagine with standard refrigerants as well, with an oil pump compressor, if the oil strainer that we have with all the oil pump compressor is clogged for any reason, dirty in the system, maybe, and we still have enough oil in the compressor, but if the strainer is clogged, the differential pressure across the oil pump is going to be very small. And as a result, we can damage a compressor even if you have enough oil in the compressor, even if the oil level controller is telling that, yes, continues operate, but in reality, it is missing oil for the moving parts.
Yeah. So that there, a technician can take the pressure from the oil pump pressure. Can you see that on there where you take the oil pump pressure? Can you highlight it?
Yeah.
And the crank. And if you do that differential and that there, that's how you would tell if that strainer's plugged, correct?
Exactly. Yes, that's the reason. I think I put a couple of pictures in the next slides that shows how to measure the oil pressure. But on the compressor, in this side of the compressor, on the oil pump side, we have the charade valves that the technicians can hook up their gauges, hoses, and measure the differential pressure. And the differential pressure basically is between 20 to 55 psi, or 1.4 bar to 3.4 bar.
Thank you for adding those units. Thanks for adding those units, because people from all around the world do use different units, so I do appreciate that.
Yeah,
one of the things that that you want to make sure is that use transcritical gauge. Even though this is the suction side, I still always recommend using a high pressure hose, high pressure gauges. Want to be always safe. Can you use low subcritical CO2 gauges? For sure, but I always recommend use high pressure gauges, especially when you're new and learning this stuff. So have the right tools.
Yes, this is a good point. For CO2 applications, we always recommend the proper tools, proper hoses, never mixed up hoses for standard refrigerants with the CO2 refrigeration system. So it's better not mix the hoses. So use always the proper tool for that.
Perfect. So
here is our solution when using CMRC and OLM IQ. This is the oil level management. Connect to the IQ module, CMRC, so we can track all the compressor operating data. We can have a graphic visualization. We can have everything what the information about everything what happened to our system. So everything is going to be recorded in the IQ module, and using the best tool, we can track everything what happened. So this is a better product as well. So, but today in the market, we have different oil level controller brands that can be used with our compressors, but the only problem is we do not have this communication like we have with the OLM IQ. So using OLM IQ, the oil level management, it is possible to control everything or to know everything what's going on.
So in that IQ, can I change the amount of flow going into it, or just monitoring how much is in there? Or do I have to change the orifice inside that? Can the orifice be changed inside that for a different amount of oil going into those compressors? Or does that need to be?
No, there is no need to change the orifice, but we have 3 different OLM IQ models. So we have it for standard refrigerants and the other 2 for CO2. And they are specifically designed for each of these refrigerants, for standards, for CO2 refrigerants.
Great.
So let's review the lubricant oils. So I put it together here, the bitter original oils. So our recommendation is use our original oils as much as possible and never mix up different oils together. So
Okay, I got a question right now because I know this is happening out there. What could happen if I mix BSE 85K and say BSG or BSE 60K and it's like half and half? What could the issues cause? Because I know this is happening out there. So tell me a little bit what could happen to the compressors if you do that.
So this will affect the oil lubrication properties. And of course, this is not recommended. We can create new, not chemical reaction, but we for sure will change the properties of the oil, and this probably will not be good for complying with to attend with all the lubrication properties we expect. So our recommendation is never.
Oh, for sure.
Never change. I mean, never mix different type of oils.
If they do, so then that means the viscosity is going to change, the pour point's going to change. Is that what it kind of you're getting at? So now, as the temperatures start to rise in your discharge, and if it gets a little high, it may thin it out a lot quicker than if it was just all the one brand of oil. Because I know in your subcritical compressors, like if you're doing a cascade system, you want to use, I think it's the BSG 68K. I can't remember your manual, but then in the transcritical, you want to use the BSE 85K. Is that correct?
Yeah, that's correct. So the BSE 60K is more used for cascade applications.
Oh, the BS. Okay,
yes,
60K,
the BSE 60K and the BSE 85K is used for transcritical CO2 booster system when we have low temp and medium temp loads and different stages. And the BSE G68K, this is more used when we have higher low pressure and high pressure. For example, heat pumps. They use this oil, but we also have this oil for subcritical and transcritical in booster system.
Okay.
So here in US, we have some manufacturers, they have their system operating with this oil using injectors.
And just so everyone understands, especially the technicians out there, the 60K and the 85K is the different weight, so the different thicknesses. Is that correct?
That's correct. In the next slide, I put it here together.
I love it.
The application range and technical data for the oils. So as you can see here, we have the application range. For example, I divide by air conditioning applications that can be also used for heat pumps, medium temp applications, low temp applications. And here we have the overview of the technical data for bitter lubricant oils. So I put these three oils together, and you can see here the flash point, pour point. You can see the density, kinematic viscosity, specific heat capacity, thermal conductivity.
Yep.
And yeah, I also have this miscibility and solubility graphs as well.
Okay, I love that. So we got a question in there. This is, and I hear this a lot. Why do compressors, and they're using bitter, but it doesn't matter if it's bitter or not. Why does the bitter CO2 compressor pump out a lot of oil? So this one thing could be due to heat. If you're running really hot and you're running 310 degrees Fahrenheit or 150 degrees Celsius, you thin that oil, so you're just going to pump more oil. Is that correct if I say that?
Yeah, I think I put oil circulation ratio here in somewhere. Let me, here, there you go. Yeah, my friend Emmanuel Reichel from Bitzer Germany has provided me with this information some time ago. And in general, in terms of oil circulation rate, it is less than 1% for basically for all bitter CO2 compressors. Okay. So especially for the new series, the TE series, compared to the previous ones, the TC. So we still we have even a lower oil circulation rate. So, but we know how to do this very well. But of course, in terms of application in the field, so it is the responsibility of the system, the manufacturer of the system, to do well with the piping lines, calculate the proper velocities to bring the oil back, avoid excessive pressure drops, things like that.
Yeah. Yeah, because this is one of the things too. We're dealing with higher pressure, higher mass flows, as well as that oil's very miscible. Like that last slide you showed, very miscible with CO2 versus other refrigerants. So this is something you got to be very aware of, because that temperature coming back to that compressor or leaving the compressor is going to affect how that oil is moving through the system.
That's correct. So especially if you compare the BSE 60K, especially you see here a wide area for of miscibility. So M is complete miscibility and P is the phase separation range. So here, that's the reason we recommended the BSE 60K, especially for low temp. And the BSE 85K also covers a wide range of application. That's the reason we recommended this oil for transcritical CO2 booster system with the low temp and medium temp stage. And the BSG 68 is more for high temp application. So you see here a huge gap for low temp, medium temp, but it is completely miscible for high temp applications.
Yeah. Okay, perfect.
Yeah, here in this slide, I'd like to show that oil change guidelines.
I love this.
So oil doesn't last forever. It's like any machine, cars, compressors. So you have to take care of the oil of your compressor. So you needed to. Here is based on our recommendation. So for field installed system, the first oil and the filter change needs to be after 100 operating hours. So no question, just change everything, filters and oil from the compressors, oil from the oil separator, oil from the oil receiver, change everything. And after that, replace oil and filters every 3 years or between 10,000 to 12,000 hours of operation, or sooner if contamination is detected. That's the reason we sell here in the US this oil test kit. This is the part number I put, but of course, this is only valid for US market because sometimes customers outside the US want to purchase this kit, but the problem is to send this oil test kit back. Sometimes it spends a lot of time to be arrived here. We work with the CPI lab, and if you are outside the US, please look for other options, labs.
You got to get a test kit and you got to be testing this stuff. But one of the big things is this is no different than HFC systems, and you need to talk to your customers. This is expensive. Like to do these changes are not cheap. Oil is expensive, but this is the conversation as a technician, as your company needs to be having with the customer right away. So the expectation is there and they understand every 2 to 3 years, we're going to need to do this. Because when you get to 5 to 6 years, these compressors, it doesn't matter manufacturer, the years, the life of that 15 years that these compressors should last, like all the manufacturers should be around that. It drops dramatically when you're not changing this oil. Think about your car. That's what I tell them. Just like they're changing it every 6 months or every so many thousand miles or kilometers. It's the same thing with any compressor. We got to be this. So have that conversation. It is a tough conversation when you're going to your customer and say, this is going to be a $25,000 bill, but you got to have it. And if you do it up front, it's going to be very, very important.
Exactly. Yes. And here, in case you needed to send the parameters to lab, here we put together what we recommend if all these parameters exceed the the recommendation values. You have to change the oil immediately. For example, air particles above 50 ppm, you have to change the oil. Water content, especially for the BSE 60K and the 85K above 150 ppm, just to know that if you grab a brand new oil can, the ppm, of course, is lower than that. It is about 30 ppm. But for used oil, if you grab a sample oil sample and send it to a lab, if it is above 150, you have to change the oil. And
I still think that's too. I say 100. That's what I know it's 150 in your manuals, but I say 100. Because when I'm in my CO2 course and I'm teaching the technician how to read these, right? And this is exactly what Alessandro is talking about here. When you look at that document and it shows metal inside there, that is a problem. That is pieces of the compressor.
exactly.
And you should not have pieces of compressor in the oil. It should be oil. That's it. No more, no water, no air particles, metal. So this is so important.
Exactly. This is our recommendation. If one of these parameters exceeds the limits we recommend. So I remember once a customer contacted us to know if we have any guidelines how to filter the oil. I said, unfortunately, you have to change the oil, and especially for his installation, the oil was very dark, multiple failures, especially motor burn, and yeah, because this is if you do not follow the compressor manufacturer, of course, your compressor will not last longer. So that's the reason this is a very important recommendation to change your oil every time it exceeds these limits.
And so there's another number on there, the total asset number. Now I want to talk to you about this because this number is so important. If the oil's still full of CO2, this will fail its test. You'll have a high asset number, so you need to get the CO2 out of that. What do you recommend technicians to do to get that out of there, Alessandro?
So if for example, if the system has experienced multiple, especially motor burnouts, motor failures, and the oil is very acid, so we recommend change the oil, and you also change the filters. We have alumina, activated alumina to neutralize the acidity. But of course, multiple oil changes, multiple filter changes is recommended until the system experience lower level of acidity.
Beautiful.
So yes, just to beside this oil circulation rate graph I showed you. So when you have the oil level controller connect through the oil site glass port, so we put this sticker on every single compressor with the oil type. So the same oil level we recommend here between 1/4 to 3/4 at the site glass. We expect at this site glass from the oil level controller as well. So this is very important.
So I've got a question from Austin. Just go back if you don't mind.
Sure.
Can you explain how the suction pressure and suction superheat influences ORC, which is oil circulation rate?
So I put in this presentation what we expect to see, because we have recommendation limits for suction superheat, for discharge superheat. Sometimes discharge superheat is even more important to know if the compressor has been flooded or not. And but if you allow me, we can discuss this after this.
Yeah,
okay,
yeah.
I put that for sure.
Yeah, I love it.
Yeah.